Hi, and welcome to the I T'd Myself podcast. My name is Matthew Miniman, and this is episode 71. What can a Rube Goldberg machine teach us about operating systems? So, a Rube Goldberg machine, if you've never heard of this, you've probably never looked at a video on the internet at all, ever. And you've probably never watched Tom and Jerry or, any of the Looney Tunes or fuck, you probably didn't have a childhood. Shit, I'm sorry. Oh, God. Anyway, a Rube Goldberg machine is a machine that has a lot of different pieces to it. And typically, it's very complex. So, you initiate a Rube Goldberg machine by doing something like knocking over a stack of dominoes. The stack of dominoes then knocks into a bucket that contains a ball. That ball then rolls around in a complicated course that then knocks over a broom, which then sets off a crossbow bolt, which turns on a TV, which causes a short and burns through a rope, which releases a battering ram that breaks an egg and starts an omelet. That is kind of what a Rube Goldberg machine does. It does a lot of complicated, random shit and results in a simple output or some simple thing that needs to be done. It's been popularized in a lot of cartoons, and like I said, there's been an insane amount of people who have put in a ton of work to make super complicated Rube Goldberg machines to identify or to do just some really silly shit. And that's kind of like an operating system, if you think about it, just a little bit. We have to put a little bit better brain power and twist ourselves into knots to think about it, but fuck, a Rube Goldberg machine does no less for you. So, on that topic, or in that vein, an operating system is effectively the layer in which you as a user will then interact with the machine. It is basically a set of instructions you get to do that results in expected outcomes. But the operating system works in a lot of different ways. And one of those ways is that, or we'll cover some of that, but basically what you need to understand with an operating system is really it is how computers are. It is the bridge in which computers are able to be interacted with on a functional level by human beings. Now, there are other ways to interact with computers. Back in the early days of computing, it used to be, pulling levers and turning knobs and shit like that. They used to have these gigantic computer rooms where you had to roll around on roller skates in order to effectively reach the knobs and the switches in time. You also used to have punch cards, which would allow you to program things to the computer directly. And shit like that. That was all manual or basically null operating system where you are communicating directly with the computer itself. And there are ways to do that, but it's very difficult to do that in a way that allows you to fully utilize the capabilities of computers. So we come up with an operating system that can turn your simple instructions into complicated sets of instructions that then result in a simple output. And that's where we get that Rube Goldberg comparison, is that you're taking a simple function, knocking over dominoes, and having a simple output, breaking an egg, with a very complicated string of instructions in between. And the operating system does this a few ways. One is, or does this with a few tools at its disposal. One is the user interface, the GUI, the UI. This is a representation of things that can be done on the computer, not necessarily fully formed. but generally the operating system supports this, with base operating systems like Linux without a GUI, Unix, OS2, I'm sure, DOS, BASIC. These all utilize a command prompt. They have a shell that is essentially just you having direct control over the operating system. You are communicating directly with it by issuing commands and running programs or creating them yourselves on the fly. And this is essentially the barest form of that communication. You get to create what you want, utilizing or interact however you want with the operating system by utilizing commands and issuing instructions that through that method. Then with things like Windows and OS X and Ubuntu or I guess GNOME, you have this user interface that allows you to then have graphical representations of the things that you can do on a computer, instructions that you can issue, but it's even more succinct. There are more direct things that are listed there that allow you to do more complicated things on the processor, but end up resulting in simple output, displaying stuff on screen, so on and so forth. So there's a lot there. The UI is that representation, is the representation of the things that the operating system can do that is presented to you as a human in an understandable or intelligible way. A UI is predictable. A UI should be expected, and it should not be fucked. If you want to have a bad time, check out the subreddit UI Gore, or is it Bad UIs? I don't remember at this point. It's been so long. But it is an exercise in frustration with what people can create in the horrors that they have developed. But that being said, the user interface is how you interact with the operating system. And all of the instructions that are represented there are essentially their own little Rube Goldberg machines. They are just, hundreds and hundreds of them stacked on top of each other. And then one of the other tools that an operating system has at its disposal to do all of this is called the kernel. The kernel is the layer between your user operations and actual communication with the computer itself. So this is kind of the core of the operating system, is what you could call it. And if you are getting into computers, if you are getting into computers or IT or cybersecurity, you do need to understand what a kernel is and how it is represented in the system and exactly what it does, because it is important. But for the purposes of this discussion, we'll talk about the kernel as it is sort of the translation. It is what the Rube Goldberg machine actually is. It takes all of that. It takes that simple input and really converts it into those complicated and fucking instructions that are necessary for the computer to perform whatever task is expected of it. And so the kernel does a few things all at once, like more than a few things. It does, especially with modern computers, it does millions and millions of things all at once. But it does things like ensure that that memory addresses are in place. It ensures that drive space is allocated. It ensures that drives are actually there, and so on and so forth, and that the partition is mounted properly. And it makes sure that the processing unit is ready and accepting of commands, and that it also allows for timing and orders of operation for how things have to run. It is essentially the core aspect of this whole operating system thing, because it requires it is what is required to communicate to the different aspects of your computer. To give you an understanding, there is a concept called machine code, which is essentially language that the operating system, or sorry, that the central processing unit itself talks. And then one step above machine code in the whole hierarchy of how stuff is communicated is called assembly. And assembly is essentially a word structure that represents the machine code underneath. And your kernel converts these very complicated instructions from your programs and from the UI and from other peripherals on a machine, and converts all of that into the machine code from assembly into machine code, and eventually it results in the outputs in what you see. This is all part of the process of developing your of converting all of your commands into the expected outputs that should be there. Now, internal to the processor, there's a bunch of other stuff like microcode and all that, and we won't get into any of that. That's kind of out of scope of this, obviously, because we're talking about processor, not the operating system. But the operating system communicates directly with the kernel, is what converts all of that data appropriately in both directions. So when a command is provided to the CPU, then the kernel also handles the return of that operation and then does whatever the next instruction set is. Or helps perform that across. It helps communicate that information back and forth, back and forth, back and forth. However many times a second that's required, billions, getting into trillions. And we as users don't really see this magic that happens behind there. It's just this Rube Goldberg machine happening so very many fucking times, all the time. Balls going everywhere. Ropes falling, brooms crashing, plates spinning, all sorts of shit all at once. And the kernel handles it. And it's important to know this because in an operating system, your efficiencies are kind of dependent upon the kernel of the system. And I bring this up because it's important to know when troubleshooting or understanding performance issues on a machine, how different aspects, different peripherals, different devices interact and are dependent upon the order of operations within a kernel. Because in a operating system like Windows, disk operations are kind of priority one in Windows operating systems. And what this means is whenever there is I call it the stack because I'm a nerd and I've played Magic before, but when you have a bunch of operations that need to be done, Windows will always put anything that needs to be done to the disk up at the top. It will always have that sitting there up at the top. So it will always try to spend as much of its CPU as it can to process functional operations to the disk first. It will always do this. So what this means is if you have a bunch of disk operations, you're going to slow your CPU down. On top of that, if you have a slow fucking disk or a disk that is dying, your operating system will slow the fuck down and it will slow down the rest of your computer. And this has driven me insane a ton of times, especially having to explain this to somebody who doesn't want to replace hardware, that their hardware is insufficient for what they want to do. Because Windows requires this. Now, it's not as simple as, oh, this is just a Windows problem. Obviously, if you have the right conditions, this will affect any machine that you put out there. But it affects Windows specifically because of that disk operations thing. With the other flavors of operating systems, and I guess that's a good time to get into this now, is that there are different flavors of operating systems that behave differently. And some of them treat those order of operations differently. So, I'm not going to run the full fucking gambit of operating systems because there are so many goddamn operating systems and there are more being created every fucking day. And I know if I were to put this out there, I'm not popular enough for this yet, but if I were ever to become popular and I get that one fucking nerd, you know the guy who's like, actually, there you miss this operating system. But anyways, there's a ton of different operating systems out there, but we have primarily we have really 2, maybe 3 flavors of operating system out there right now. We have Windows, which is the legacy, used to be MS-DOS based operating system. It is now slowly morphing into its own pseudocode of Linux and DOS and a bunch of other shit all combined. Anything that Bill Gates could steal, he fucking throws into this goddamn project. It's not him anymore, but it's whoever stole his fucking throne. But Windows is the biggest operating system out there right now, simply because it is the most utilized in enterprise settings. Now, it is not the most popular or most used operating system on the planet. That is reserved for Linux-based operating systems. So there are kind of 2 flavors. There's Windows operating systems, and then there's Linux operating systems. And Linux-based operating systems exist everywhere. If you have a fucking device that has a CPU, its operating system is probably going to be Linux. Now, I'm not going to guarantee that, because people, like I said, there are fucking literally billions of goddamn operating systems out there. But if you have a broadly created device that is mass manufactured, that has a computer in it, it likely is running on some sort of Linux flavor. Now, within Linux, there's a shit ton of subdivisions and distributions in there. OS X is one of them. Android is one of them. iOS is one of them. These are all different flavors or different distributions of Linux. And Linux is a very good operating system to use on a system that does one specific task very, very, very well. And it can be a user-based operating system for a lot of stuff, but generally Linux is intended for use behind the scenes without being touched. It's kind of one of those operating systems that is scared or shy. It doesn't necessarily like to be on your face. Most Linux operating systems would say 99% of Linux operating systems or devices that are running Linux operating systems don't have a GUI. They are completely shellless because they are running without any interaction. And to give you sort of an idea of what this is, the vast majority of the computers in your car are probably running some flavor of Linux. Anyway, the whole concept of this is that there are different flavors of operating systems. And beyond just Windows and Linux, there are other operating systems. There is an operating system that is completely written in assembly. So the kernel is effectively bare to the user. You are not doing anything that is overtly difficult or strange. The Rube Goldberg machine is essentially one layer less than what it normally would be. It is kind of cool to see. If you want to see the assembly OS project, it's pretty neat. It runs Doom, so that's good. But yeah, for the purposes of most people, you're going to have those 2 different operating systems. And if it's got an operating system on it and it doesn't have a monitor and keyboard and mouse attached to it, it's probably running Linux, because shit runs on Linux. All that being said, your operating system is important to you as the user, because it is that interaction. It is that key piece that converts your very simple instruction. I click the mouse button, I open Facebook. That is what the operating system essentially is. It takes that very simple instruction set and turns it into a complicated number of instructions and orders and operations, and then has a simple output. Simple being in quotes there. Because, cracking an egg, not necessarily simple. There's a lot that has to go into cracking an egg. Where you're going to crack it? How are you going to crack it? Is there any shell in it? Man, that's really complicated. Anyway, beyond that, your operating system also interacts with the peripherals and other core aspects of your computer, such as memory or hard drive. And typically it does most of this through drivers, which are what tell your operating system how to interact with those devices, what the operating system is allowed to do with those devices, and in turn, what those devices are capable of. If you have an issue with a device, your driver is probably the problem. This is not so much a problem now in the reality that is the internet and the oversharing of literally every fucking thing on the planet. But the driver issues that we used to run into where we had to plug a thing in, and if it didn't work, we installed the driver, and then the device kind of worked because it was a compatible driver, but not the true driver, and so we had to install another driver in order to get it to work fully. Yeah, you don't have that anymore because your operating systems kind of have a generic approach to how to interact with all devices, and they have drivers specifically written for just about every other peripheral out there. So, in the grand scheme, in installing a very specific driver for a very specific device no longer has to happen because of the way the operating systems handle that now. But do know that there is that functionality that happens in the back end. That's another thing that your kernel kind of handles is that control of that device, the communication of the device to the underlying CPU and operating system, or underlying CPU and machine code, and then presents that to you as the user through the operating system, through the UI, through whatever instruction set is required. Printers print, mouses click, webcam spy. I don't know. It's all there. So, with all that being said, your operating system is also something that does need to be installed, typically by the user or on your behalf, and then you need to be able to interact with it accordingly. We'll cover in future episodes things like user creation and so on and so forth, and how operating systems interact with different things like networking, and the other key components of modern day computing. But know that your operating system is really there to take your simple fucking instruction, make it a very complicated instruction set, trapping mice, capturing children, blowing up asteroids, all to simply combine and create a small and insignificant function of you posting your cat pic on the internet. Well, I hope you guys have a great day.